What does a tiny matchstick and a 3,000-ton rocket have in common? They are both simple energy storage devices. One lights a candle, the other lights up the sky. But before we light the fuse, we have to understand the problem. We live at the bottom of a deep gravity well. To leave Earth, we have to pay an energy debt. In physics, we call this overcoming gravitational potential energy. Imagine gravity is a giant, invisible rubber band pulling everything down towards the center of the Earth. To stretch that band all the way to space, we need a massive injection of kinetic energy. Motion. Where do we get it? We can't plug a rocket into a wall. We need to carry our energy with us. This is chemical potential energy. It's energy stored in the atomic bonds of molecules, waiting to be released. Rocket fuel is chosen for its incredible energy density, packing the maximum amount of potential energy into the smallest possible space. But there is a catch. To release that energy through fire, you need oxygen. On Earth, cars and jets just grab oxygen from the air for free. But space is a vacuum. There is no air. This means a rocket is an isolated energy system. It must carry its own air, usually in the form of liquid oxygen. This is why a rocket is mostly tank. It is a flying thermos bottle, keeping volatile chemicals stable until the exact moment we need them. When we mix them in the combustion chamber, we trigger a violent chemical reaction. We are breaking the bonds of the fuel molecules. This releases the stored chemical energy and transforms it instantly into thermal energy. Now, we have a chamber full of high pressured exploding heat. But heat just wants to expand in all directions. That's useless for flight. We need to focus it. Enter the de Laval nozzle. It's not just a funnel, it's a thermodynamic machine. As the gas is squeezed through the narrow throat, it accelerates. Then, as the nozzle widens, the gas expands and cools rapidly. This captures the random thermal energy of the heat and forces it into a straight line. We have successfully converted chaotic thermal energy into directed kinetic energy. This is Newton's third law in action. We aren't pushing off the ground. We are throwing mass, which is the gas, down at hypersonic speeds. The equal and opposite reaction pushes the rocket system up. But here's the catch. The energy density of our fuel is high, but so is the cost of carrying it. A rocket is essentially a flying gas can. On a Saturn V, 85% of the entire mass was just jet fuel. This leads to the most brutal rule in rocket science, the tyranny of the rocket equation. It works like this. To lift a payload, you need fuel. But fuel has mass, so you need more fuel to lift that fuel. But that fuel has mass too. This loop is mathematically defined by the Zagolsky rocket equation. The scary part is this symbol, ln, or the natural logarithm. It dictates diminishing returns. It means that if you want to go twice as fast, you can't just double your fuel. You have to increase it exponentially. If we try to build a single stage to orbit rocket, one giant ship that never drops anything, it would have to be 99% fuel and 1% structure. That is engineeringly impossible. The walls will be as thin as soda cans and will collapse under the stress. So, we cheat. We use staging. Think about a car. When you drive, your gas tanks get lighter, but the heavy metal tank stays attached to the car. In spaceflight, carrying an empty metal tank is a crime against physics. Imagine running a marathon with a 100-pound backpack full of snacks. On mile 20, you've eaten all the snacks. If you keep wearing the empty backpack, you are wasting energy carrying dead weight. If you drop it, you instantly run faster with the same effort. This is Newton's second law. Force equals mass times acceleration, or F equals ma. If our engines push with the same force, but we suddenly cut the mass in half by dropping a stage, our acceleration must double. By shedding the empty stage, we instantly optimize the physics of the system. We eliminate the need to lift useless structures, which allows the remaining fuel to be converted entirely into velocity for the payload. We have successfully turned chemical bonds into blinding speeds and hacked the math of masses. But going up half the battle, to stay in space, we have to stop fighting gravity and start using it.